Okay, hi everyone. For today's lesson, I'll try to deliver by using my laptop. Reason being is I'm thinking whether I can like save some papers and be more environmental friendly or not by doing so. So I'm just trying out and see whether it's effective or not. Okay, so for today's lesson, we are still under topic one for your Pure Max 3, which is algebra. However, if you are referring to your textbook, please go to chapter 7, which is further algebra. Okay, for today's learning outcome, we are just learning one thing today, which is how do we express a rational function in partial fraction. So remember the keyword today and what you are going to learn is basically partial fraction. So there are three cases that you will need to learn, which is these three. So later we'll be looking at this one by one. So don't worry. It's actually a very technical stuff, and I believe that all of you should be able to get it. Okay, so before we move into the technique part, let's try to talk about what is that mean by partial fractions first. Okay, so by looking at this example, I'm pretty sure that most of us know how to do this. Okay, so when you try to add them up, so what you will try to do is you will try to make your denominator the same, right? So which means you will try to change this to like 2 times x plus 1, then your denominator also multiplied by x plus 1. Then after that, for your second term, you are going to times x minus 2, so you will get the denominator that is the same with your first term. So after you did this, then only you have the same denominator, and this is the time that you can add them up, right? So 2x plus 2 plus 3x minus 6, and then divide by x minus 2, x plus 1. So now you can try to do your operation here. So 5x minus 4, which gives you x minus 2 and x plus 1. Okay, so all of us know how to do addition and subtraction from the simple fractions. But my question here is, how can we do the reverse? So meaning that instead of like doing plus and from the simple fraction to get a compound fraction, can we actually express this compound fraction into a simple fraction? Okay, so what we are learning today is just this process, meaning that the reverse process of doing simple to compound, we are going to change the compound to simple. So what we are learning today is the reverse process of splitting the algebraic function or fraction into two or more simple fraction. So this process is called as partial fraction decomposition. So from the example just now, we are doing like how do we add them up then to get this one, right? So meaning that partial fraction decomposition is basically the opposite. How do we get this from the compound function? So the answer that we get when we do the reverse process is called as partial fraction. Okay, so for today's lesson, the main focus will be learning how do we split the fraction into two or more simple fractions. So why we need to do this is because of when we decompose it to become a simple fraction, it can be like very helpful for us for the problems for binomial expansion or even differentiation and integration, which you will learn in future. Okay, so before I continue to the technique, right, I want to talk about something first, which is what is that mean by proper algebraic fractions and improper algebraic fractions. Okay, I think you know that in fractions you also have proper fractions and improper fractions, right? So meaning that if we have like 1 over 4, and let's say I have 7 over 4, so if the number for your numerator is smaller than the denominator, this is like the proper one. Then after that, for anything that when you have your numerator is bigger than your denominator, this is like the improper fraction, which you can always change it into like a mixed number, right? So the same thing in algebraic fractions, you have proper and improper also. But the difference is just that because if we talk about algebra, meaning that we have an unknown or like a variable in your numerator or denominator, right? So how are we going to know exactly like whether it's bigger or smaller? So we'll try to use this. So if you have a fraction that is the function of px and the function of qx, where p and q are polynomials. So if your degree of your px is smaller than qx, meaning it's proper. Okay, so if I were to give you an example, then maybe it will be like if I have x minus 13 and then x my plus 1, then x plus 3. Yeah, so you can see for the numerator, the degree is 1 because the highest power that you have is 1. For your denominator, what is your power here? 2x times x, you are getting x squared, right? So the power or the degree here, the highest power or the degree here is 2. So that's why 1 and 2. So the degree of your numerator is smaller than the degree of your denominator. So this is a proper function, proper fraction. So the same thing if I have like 3x squared plus 5x minus 3, then I have x squared x plus 1. So this is also a proper because the degree for numerator is 2 and the degree for denominator is 3. So as long as you have the degree of your numerator is smaller than the degree for your denominator, that is a proper algebraic function, fraction. So remember, it must be smaller. It cannot be equal. So anything that has a degree that is greater or equal for the numerator and the denominator, then it will be called as improper. So for example, if you have like x squared plus 3 divided by x minus 1. So for this one, it's improper because you can see that for numerator, the degree is 2, and for denominator, the degree is 1. So the same thing, even I have 2x squared plus 5x minus 3 divide by x plus 1, x plus 2. So you can see that for numerator, the degree is 2. For denominator, the degree is also 2. So if they are same, it's under improper as well. Okay, so for proper fraction, it must be smaller than. So for today's lesson, we'll be trying to look at the part for the partial fraction for proper algebraic function first. Okay. Okay, so now we are going to into the main part for the lesson, which you will try to look at 3 types of partial fractions for proper algebraic fractions. So let's start with the simple one first, which is the denominator has distinct linear factor. So for each type, I'll try to show you how the formula comes from in a simple way. Then you will be able to understand like why we are trying to split the fractions like this. Okay, so let's try with this. If I have 5 over x plus 3 plus 4 over x minus 4. Okay, so when you want to calculate this, then what you are trying to do is you will try to times them. So this is the same idea like the first sample that we did just now. So since this is something that you know how to do already, so I think you can try to do it on your own also when you are looking at the video. Okay, then you'll be able to get 5x minus 10 plus 4x plus 12 divided by x plus 3, x minus 2, so that you get 9x plus 2 and then x plus 3x minus 2. Okay, so now I want you to try to look at this equation in a reverse form. So meaning that let me just try to write this down, copy this again. Okay, so I hope that you can try to see this. So for any compound fractions, that you actually has denominator of linear factor, when you try to do the reverse for partial fractions, you are going to get something with the denominator as your linear factor. So when you look at this question, right, you can see that when I do the reverse, I can see that I will have one fraction with the denominator x plus 3. I have the other fractions that I have a denominator of x minus 2. So meaning that for each linear factor ax plus b, there is a partial fractions a over ax plus b. So meaning that I do not need to care about what is the numerator, so I only look at the denominator. So if let's say I have ax plus b and cx plus d, when I try to decompose this fraction, I will be getting two fractions which has each of the linear factor, which is ax plus b and cx plus d. So for the AB, it will be like the two number here, which we will need to find out by using the equation later. So the same thing, if I have like three terms here, meaning I have three linear factor, right? So meaning that I will have three fractions with the constant as the numerator. Then after that, for my denominator, it's going to be the exactly the same like the linear factor that I have in the compound fractions. Okay, don't worry. So we are going to look at two examples now together. So let's look at example 1. So you need to express this fraction in partial fraction. So how are we going to do that? Okay, let's copy down first. So from this fraction, you can actually recognize that there are two linear factors that is different. So meaning that you see you have 2x plus 1 and x minus 3, which is both in linear form and they are different. So meaning they are distinct linear factor in this fraction. Okay, so what are we trying to do is, you remember just now from the notes itself, we know that for every linear factor, you can write it in the form that is a over ax plus b. So meaning that we can always change it into a. So this a is the constant that we need to find. Divide by the first linear factor, which is 2x plus 1. Then after that plus, so the same thing, another constant, then divide by your second linear factor, which is x minus 3. Okay, so after you have read it in this form, then your uh, task now is to get what is your A and what is your B. So how are we going to do that? So let's try to change the whole equation into an equation that without denominator, because that will help us to solve the equation much more easier. So the whole thing, I will try to multiply 2x plus 1 and x minus 3 so that I can eliminate the denominator part. So what I will left with is 2x minus 13 is equals to a x minus 3 plus b 2x plus 1. Okay, I hope that you are with me. So meaning that when you use a divided by a over 2x plus 1, you multiply by the two factors here, then definitely 2x plus 1 is going to eliminate each other, then you left with x minus 3. So same goes to b. Okay, so after you have this, then now you can try to solve it. So when you look at this, maybe your first idea is that I can try to actually come up with two simultaneous equation, which one for the form of x and the other one for constant. You can do that, so meaning that 2 will be equals to a plus 2b. Then after that, negative 13 will be equals to negative 3a plus b. So you have two equations, then you try to solve simultaneous. Okay, but for this chapter, I'm going to show you the other method, because I think that if let's say you are going to solve something that is not easier like this, not an easy equation like this, then you are going to I mean the simultaneous equation can be like very long working itself. Okay, so one method that you can learn is that how can we try to get one by setting the other variable to be 0. So you can see this one is a times x minus 3. So here is b times 2x plus 1. So if let's say I want to get the variable of a now, so what is the x that I can set so that my b will become 0? So I can set x as negative 1 over 2, because when I put x equals to 1 over 2, negative 1 over 2 here, I will get this term to become 0. So 0 times b, I'll get 0, then I can get my a. So meaning that the first thing that I can do is let x equals to negative 1 over 2, because I want to get my a. So I will try to substitute the x into the equation. Okay, so a, then negative 1 over 2 minus 3. So same thing, you just put it in for the first time. So 2, 1, negative 1 over 2 plus 1. So you can see that when you try to solve here, then you are getting 0. So this is how you make your b disappear. Okay, so but in front you need to solve it like normal lah. So you have negative 14 equals to negative 7 over 2a. So since the b becomes 0, so you don't need to write that. So you can find your first variable, which is a. Okay, so after you get this, then now when you want to get your b, so meaning what you will do, you want to try to, of course, you sub any x, you will be able to get the answer as well, because you have your a already, right? But then let's try to make it easier. Then maybe we can try to make the term of a to become 0. So let my x to become 3. Okay, so when my x is 3, so meaning I have 2 times 3 minus 13 equals to a, 3 minus 3 plus b, 2, 3 plus 1. So you can see that my a now is becoming 0. So that's why 6 minus 13, I get negative 7 equals to left with 7b. Okay, so now I can try to get my b here, which b will give me negative 1. So from here, I get my a and b. So now I can definitely write down my answer. Okay, so meaning, I'm sorry, I hope that you have written down in your own paper so you can see that. Yeah, I think this is a problem of using the screen. Okay, so you need to write down again your answer. So 2x plus 1, x minus 3. Okay, so you remember just now, a over 2x plus 1 and b over x minus 3, right? So you need to write down your a is 4. So that's why 4 over 2x plus 1. Then after that, b is negative 1. So minus 1 over x minus 3. So this is how you get your partial fraction. Okay. So if you have extra time, then what you can try to do is you can try to solve them up and see whether you can get this answer or not. This is how you can try to check in your exams itself. Okay. So now let's try to look at example 2. Okay, so let's look at number 2. So the same thing here, but what you can realize here is instead of like having a linear factor, you actually have a quadratic factor here. So how can you do that? So it's like very easy. Like normally, how are you going to change a quadratic equation into a linear equation? So meaning that you are doing your factorization, right? So instead of writing like 3x squared minus x plus 2 and divide by 3 plus x squared minus 4, then what you can try to do is the first step, then meaning that you need to do factorization so that you can get linear factor instead of like having a quadratic factor. So it will become 3x squared minus x plus 2 divide by, so how do you factorize this? So you will get x minus 2 and x plus 2. Okay, so from here you can see that you have 3 distinct linear factor here. So when you try to decompose it, then meaning that you will have 3 lah. So a, b, and C. So each of the fraction will have each of the linear factor. So 3 plus x, x minus 2, and x minus 1. Okay, so it will be always in this form if your factor is a linear factor. So the same thing now, we are trying to change everything into an equation without fractions. 3x squared minus x plus 2 equal to a times x minus 2 x plus 1. So this is the example that you can see if let's say you want to expand it and then try to solve simultaneous, right? Then it will be like a very long working because what you are having now is not only a linear factor. So each of the factor you are going to times 2. So sorry, 3 plus x and after that x minus 2. Okay, so after you have get this, then the same thing. So if let's say you want to try to get a first, then what you can try to think is how can I make b and c equals to 0. So you can see that b and c, they have a common factor here, which is 3 plus x. So meaning I can substitute my x as negative 3. So let x equals to negative 3. Then I try to substitute 3 negative 3 2 minus negative 3 plus 2. It will be equals to a negative 3 negative 2 and negative 3 plus 2. Okay, so since we already know that this is 0, then maybe we can just write it like b times 0 plus c 0. So, but if you want to skip this step, then please make sure that you already really know that your equation is going to be 0. Okay, so if not, I'll try to recommend you, so try to write down everything for a safety purpose. Okay, so 927 plus 3 plus 2, it will be 32. So equals to negative 5, so 5a. Okay, so a will be equals to 32 divided by 5. So we do the same thing for b. So if we want to find b now, how can we make a and c become 0? Okay, so meaning that if we want to find b, then what we need to do is we need to let our x to be 2 so that we can get our b, right? Because a and c have a common factor, which is x minus 2. So when we let our x to become 2, meaning that I will need to substitute 2 at all the places for the x. So since I already know that my a will going to be 0, so please double check again when you want to write that down. So 2 minus 2, you are getting 0. So 0 times anything, you are still getting 0. So a times 0 and then plus b, 3 plus 2, 2 plus 2 plus c is going to times 0 as well. Okay, so let's continue. So when you try to add them up together, 4 you are getting 12 and then equals to 5, so 20b. Okay, so your b will be equals to 3 over 5. Okay, then we need to do the same thing now, check for c. So for us to find the answer for c, our AB needs to be 0. So their common factor is x plus 2. So meaning we need to substitute our x as negative 2. So let x equals to negative 2. So now let's try to change. So 3 negative 2 square and then minus negative 2 plus 2 equals to your a will become 0, your b also will become 0, and then plus your c. So c will be 3 plus negative 2. Okay, and after that you have the other one, sorry, this should be a bracket. Okay, then the other one, negative 2 minus 2. So this is for c. So you will be getting 16 equals to 5, so negative 4c. So your c will be negative 4. Okay, so the same thing after you have get your ABC, now you need to substitute. So please make sure that you don't leave your answer like this in your last step. So copy again. So yeah, I'm sorry that I think the screen here, I mean the bad part about this is I cannot have everything on one screen together. So you might need to look at your own paper when you try to follow the lesson. Okay, so same thing, try to copy down your original fraction, then it will be equals to, so your A is 32 over 5, right? So how are you going to write that? So 32 for the numerator part, and then 5 over 3 plus x. Okay, then after that for your B, it's going to be like plus. So since you get 3 over 5, right? So 3 over 5, then after that your denominator is x minus 2. Then the last one, negative 4 and x plus 2. So this is how you leave your last answer. Okay, so this is the part for our case 1, which means that for all the partial fractions that we need to solve, the denominator are distinct linear factor, meaning that you are having a linear factor that is different than each other. So now we'll be looking at case 2. Okay, so for type 2, we will be discussing for the denominator which has repeated linear factor. So if you recall for the type 1, you must remember that it only applies for linear factor that is totally distinct. So meaning that you have all different linear factor in your denominator. So for type 2, it applies to the denominator which has repeated linear factor. So in your syllabus itself, you only will be asked for the questions where the linear factors is repeated like twice. So actually this I mean there is a much more general formula that you can find if you have the linear factors with have power like 3, 4, 5 and so on. But then your syllabus only require you to learn up to power 2 only. So we are going to focus on that part. Okay, so the same thing, I will try to explain to you how the formula comes from first. So just by doing a example here. Okay, so if let's say if I have something that is 3 over x plus 1 equals to 2, sorry, not equals to, plus 2x plus 1 square. Okay, so when I want to plus them together, then what I'll be doing, because I have the second one is the square for the factor that I have the first term, right? So I'm not going to multiply them each other. Then I'm going to just change my first term into x minus x plus 1 square. So I will be doing 3x plus 1. Then after that, x plus 1 square plus 2x plus 1 square. So I'll be getting 3x. So since it's easy, then let me just try to write down the answer. Then x plus 1 square. Okay, so what you can realize here is, if I try to copy this down, so when we talk about partial fractions, meaning that we need to do the reverse process, right, from here to here. So you can see that when I have something that is repeating in the denominator, it means that I might have two fractions that has a linear factor of like power 1 and power 2. So in general, meaning that if I try to change this to x plus 1 power 3, then I will have three partial fractions, which is the first one is x plus 1, then second one x plus 1 power 2, then the next one x plus 1 power 3. So in your syllabus, you only need to learn up to power 2. So you just remember, if you have anything that is a repeating linear factor, which you have the indices of 2, meaning that you will need one partial fractions that is ax plus 1. So meaning this is like the power 1. Then after that, you need another one, which is power 2. because what you are trying to do is like the reverse process here, which can be proved here. Okay, so this is the second formula that you can remember. So the same thing, we are trying to look at two examples as well. Okay, so let's look at example 3. So you can see that this fraction, they have a denominator which has two repeated linear factor, which is like x minus 4 and x minus 4, right? So that's why we need to use this formula to help us to do this. So if you have this case, then the same thing. Let's try to copy down your given fraction first. Okay, so now you need to split it into like two. So one is the exactly the same linear factor, but with power 1 only for the whole function here. Then for second one, it will be following your original function. So it will be a, okay, over the first one, x minus 4, and then plus b, and the other one, which is x minus 4 square. Okay, so now we need to do the exactly same thing like how we solve for the other equation just now. So 2x minus 11 will be equals to a times x minus 4. Okay, so the same thing, the whole equation I will need to times x minus 4 square. So I can get rid of the denominator. So plus b. Okay, so since we have this situation, then maybe let's try to find b first. It will be easier because we can let a to become 0, but for b is like, because we don't have any factor here. So let x equals 4. Okay, so 2 times 4 minus 11 equal to, so your a here will become 0 already, and then plus b. So you will get your b as negative 3. Okay, so since I have enough space here, I'm just going to write it here, continue for my b. So what I can try to do is I cannot substitute anything to make b become 0, right? So I can just substitute anything as long as it's easy for me to get the answer. So maybe I will try with let x equals to 0. Okay, so when my x equals to 0, I get 0 minus 11 equals to a, 0 minus 4, and then plus b. Alright, then continue. I get negative 11 equals to negative 4a plus b. So since we already gotten our b just now, right? So negative 11 equals to negative 4a minus 3, which will give me 4a equals to 8. So I get my a as 2. Alright, so by doing this, then I already get my a and b. So now I can rewrite the whole thing. 2x minus 11 over x minus 4 square equals to 2 over x minus 4. So my b is negative. So minus 3 over x minus 4 square. Okay, so the same thing, if you want to check, then you can try to solve this and see whether you get your given equation or not. Okay, so let's try to see example 4. Okay, so for number 4, so this is the questions that with combination with the type 1 and type 2, which you can see that there is distinct linear factor and there is the repeated linear factor as well. So how are we going to solve this? Then you need to use both. So meaning that, let me try to copy down first the given the given fraction. Okay, so follow the same thing. Every linear factor, you should have a partial fractions that is a over x minus 2, right? So you finish for the part for x minus 2. So now your repeated linear factor is the place for 2x plus 3. Then you need to apply the same thing. So plus b, the first one is 2x plus 3, and the second one is 2x plus 3 power 2. Okay, so this is how you do that. So the same thing, 1 minus 9x minus 8x squared will be equals to a multiply with 2x plus 3 square plus b. I have x minus 2, 2x plus 3 ones, and then plus c is only x minus 2. Okay, so you must make sure that this step you don't do any mistake here, because yeah, it will affect the following working. So same thing, let's try to find our a first. So for us to get our a as 0, then for us to get the answer for a, you need to make your b and c become 0. They have the common factor that is x minus 2. So that's why I can always let my x to be 2. So 1 minus 9 times 2 minus 8, 2 square equals to a 2 times 2 plus 3 square plus b 0 and c also 0. Okay, so after we have got this, then continue to solve it. Negative 49 equals to 7, 7, yeah, so 49 as well. So a will be equals to negative 1. So let's continue with b. So to get b, then we might need to, what do you think? Yeah, so you see for a and c, they do not have the common factor. So maybe for this case, let's try to get c first. So for us to get c, then you might need to let your x to be negative 3 over 2. Okay, because the common factor is 2x plus 3. So that's why 1 minus 9 negative 3 over 2 minus 8 negative 3 over 2 square equals to, so a will get 0, b will get 0 as well, and then your c will have negative 3 over 2 minus 2. Okay, then you can continue. 9 negative 7 over 2 equals to, yeah, same thing here, negative 7 over 2c. Okay, so you'll be able to get c equals to 1. All right, so from these questions, you can see that B and A and C, they do not have the common factor, right? That meaning that you might need to substitute something. Then after that, to get your A and B answer inside, then after that, to put inside your A and C so that you can get your B. So let's do the easiest calculation, which we try to let our x to become 0. Okay, so substitute 0 for the whole equation. So 1 minus 9, 0, minus 8, 0 square equals to a, and then 2 times 0 plus 3 square, and then plus b, 0 minus 2, 2 times 0 plus 3, and then plus c, and you have 0 minus 2 as well. Okay, so same thing, try to solve it. So in front here, you will be getting 1 equals to 9a, and then plus, it should be minus, is it negative 2? So yeah, minus 6b and minus 2c. Okay, so now you can substitute. Your a is negative 1 and your c is 1. So 1 equals to 9, your a is negative 1. B is the unknown that you want to get, negative minus 2, then times 1. Okay, 1 equals to negative 9 minus 9b minus 2. So you are getting 6b equals to negative 12. So which will give you b equals to negative 2. So same thing, rewrite again your whole fraction. 1 minus 9x minus 8x squared divided by x minus 2, 2x plus 3 squared. Okay, so put in your a, which is -1. So it will be -1 over x minus 2. And then minus your b is -2, right? So -2, then 2x plus 3. So your c is 1, so plus 1 over 2x plus 3 to the power of 2. Okay, so same thing, you can try to check it, you can try to like solve this again to check whether you get your given equation or not. Another easy thing to do is you can just check like for example, if let's say you want to combine them together, right? Then you can definitely check that whether you have the denominator given here or not. So if I were to plus them all together, then I know that I'll definitely need to times x, 2x plus 3 power 2 here, then I'll need to times x minus 2 and 2x plus 3, and this one need to times x minus 2, then I can roughly know that my denominator is correct. But I mean, of course, for numerator part, I'll need to do it to solve the whole thing lah. Okay, so now let's look at type 3. Okay, so this will be the last type that you need to learn. So if you remember in your example 2, just now we deal with questions that is a quadratic factor, but actually we can factorize it into a linear factor. So now we will talk about how if the denominator has a quadratic factor which cannot be factorized, then what we need to do. Okay, so something to remind you is that actually the syllabus for the partial fractions under this topic, right? So personally for me, I think that the syllabus itself is very I don't know what's the words to say, but that they actually have a lot of like constraint in the part that they already give you the level of difficulty. So meaning that you are going to learn like this difficult, but then your questions is not going to beyond that. So that's why the thing that you are going to learn is like not very general. I mean that actually you can learn further than that, but then they actually only give you like specific type that you need to learn. So like for example, the type 2 that I said just now, right? So actually a better approach will be you need to learn like the repeated linear factor, even you have like power 2, power 3, power 4 and so on. But then for the syllabus itself, you only required to learn up to power 2. So same thing to type 3, where you have the quadratic factor that cannot be factorized. For your questions, right, you only have a quadratic factor that is in terms of like cx squared plus d. So meaning you only have like x squared term and the term that is constant. So you will not have like question that you have x. Okay, so yeah, I'm just going to tell you this so that you are aware of how's the difficulty looks like. Okay, so the same thing, I'll try to show you an example for how the formula comes from as well. So let's try to solve this. So 1 over 2x minus 1 plus 3x minus 1 divide by negative x squared plus 3. Okay, so if I need to solve this, then what I will need to do is I will need to multiply them, right? So let me try to do this like quickly. So I'll be able to get 2x minus 1 negative x squared plus 3. So same thing for the other term, then it will become a quadratic at the top as well. So let me just do the quadratic, okay? So we can save more time here. So 6x squared, then you have negative 2x, so negative 5x and plus 1. So divide by 2x minus 1 negative x squared plus 3. So equal to 5x squared minus 5x plus 4 divided by 2x minus 1 negative x squared plus 3. So you see when I try to reverse the process, then I can see that for the part for the linear factor, right, is going to be exactly the same like what we have learned just now. So one constant over the linear factor. So for the part if I'm having a quadratic factor which cannot solve, then meaning that when I try to change it back, then I might have a linear at the top. So because what we are trying to solve here is only for the proper algebraic fraction, right? So you will not have anything that is like the power for your numerator is bigger than the denominator. So I already know that here is power 2. So that's why for any quadratic denominator, for my numerator part is going to be linear or even a constant. So if it's a constant, meaning that the term for x is 0. Okay, so you can just remember anything that you have a linear and a quadratic, meaning that the linear will follow constant over the linear factor, then after that bx plus c. You are not going to have like independent questions, something like 2x plus 3 divided by x squared plus 3. You won't have this type of thing because uh you already know that for x squared plus 3 you cannot factorize, then this one cannot be more simple than this anymore. So that's why for this type of fraction, it will come together with another linear factor, so it will always be in this form. So that's meaningless at all. There's no point that they want to give questions like this. Okay, so you can just remember the formula. So it's very easy lah. You remember for a linear factor, then you left with a constant. For a quadratic factor, then you left with a linear form at the numerator. Okay, so let's try to look at two examples also. Okay, so let's try to look at number 5. So when you look at this question, you can see like one linear factor and one quadratic factor, right? So you just follow the formula. So the first linear factor, you will have one constant for the numerator. So it's going to be equals to a over 2x plus 1, then plus bx plus c over x squared plus 3. Okay, so you can just continue by getting rid of the denominator. So my 6 minus x equals to a times x squared plus 3 and plus bx plus c. So make sure you must put them into a bracket, okay? So if you didn't do that, then later you forgot, you thought that only c need to times with 2x plus 1, but it's actually the whole term. So it depends on you whether for this step you want to expand one more, which like bx times 2x plus 1 and c times 2x plus 1. So depends on your preference lah. So for me, normally I'll just leave it there, then I'll continue to expand that. So if you do not like this form, then what you can try to do, you can try to change this into like bx times 2x plus 1. Then after that plus c, then 2x plus 1. So it's going to be the exactly same thing. So okay, maybe you just write like this so it's easier for you for first time. Okay, so a, then x squared plus 3. So meaning that what I'm trying to do is like bx times the whole term, then c times the whole term. So I don't need to expand it furthermore. All right, so the same thing, let's try to see whether I can make my bc become 0 or not. Yes, because they have the same common factor here, which is 2x plus 1. So I can always let my x to be negative 1 over 2, so that I will be getting 6 minus negative 1 over 2 equal to a negative 1 over 2 square plus 3, and I'm left with b 0 is bx 0, then c 0. Okay, so here I'll get 13 over 2 equals to 1 over 4 plus 3. I will get 13 over 4a. Okay, so I can get my first answer, which is a is equal to 2. Then I continue for the next step. How can I get b? So if I want to get B, meaning that A and C must be 0, right? So since there is no common factor, then maybe we can move on for C first. So for C, when you look at A and BX, you actually do not have anything that is similar also. So any idea that how can you try to do that? Yeah, okay, so you can't actually make A and B both become 0, but you already got your A. Can you try to make your B 0? Yes, you can, because B times X, correct? So for the BX here, when I try to let my X to be 0, my B will definitely be 0 already. Then I left with the A term, which I have my A, so I can actually get the answer. So I will do 6 minus 0 equal to A, 0 square plus 3 plus, so B, I will times with 0, right? So anything behind is not important anymore. So maybe I'll just write the whole thing. Okay, plus 1. Then after that, plus C, 2, 0, plus 1. Okay, so 6 equals to 3A. So B, the whole thing becomes 0, so plus C. So since that I already got my A as 2, so I can put it in plus C. So this is how I get my answer, C equals to 0. So since I have A and C, so now I can substitute any number for my X so that I'll be able to get the other. So normally we will sub the number that is like very easy for us to count. So maybe we have -1/2, so let's do 1. Okay, so 6 minus 1 equals to 2, A, and then 1 square plus 3 plus B 1, and then 2x plus 1 plus C, and is 2, sorry, the x here should be 1, right? 2 1 plus 1 plus C, 2 1 plus 1. Okay, so 5 equals to 3 4A plus 1 2 3 3B plus 3C also. So now we can substitute the number that we got. So 5 equals to our A is 2. The B is the number that we want to find. So C is 0. So we have 3B equal to -3. So my B will be equals to -1. So now I can write my answer. So I have 6 minus x over 2x plus 1, x squared plus 3 will be equals to 2 over 2x plus 1. Then what is my second one? I have bx plus c. So my b is -1. So since I already know that my c is 0, so I'll just -1 lah. Okay, so my second term is x squared plus 3. So the same thing, you can try to solve this out and check whether you can get the answer or not. Okay. Okay, I'm just going to show you very quickly, do you have an alternative for the number 5 here? Because I think it's very hard for you to realize the second one, which you need to find your BC. So if you can't recognize that you can actually find C first, then after that go to B, right? What else you can try to do? So you have the other method that is called like you try to equate the coefficient like in front of your x. So meaning that instead of like making one of your term become totally 0, right? The other thing that you can try to do is by doing comparison. So meaning that if let's say now I already got my A, right? So uh I mean I can't actually identify that what is the common factor here, so I can try to use this method. So I would want to check for the first one, which is when I look at this one, I know that it's 6 minus x. So I know that when I try to solve this thing out, right, the coefficient for my x square should be equals to 0 because there's no x square for my term here. So what I will try to do is I'll try to equating the coefficient of x square. Okay, so what I will try to do is I know that for the front part here, I don't have any x square, so the coefficient for the x square there is 0. Then after that, if you want, then you can try to write like this first. Okay, so how about the part behind? So you can see that for C here, definitely you do not have any x square. So for the part here, yes, you have is 2bx squared. For the part here, you have ax squared. So you know that you have a plus 2b x squared. So this is what is that mean by equating the coefficient of x squared. So by putting them like this, so meaning I know that 0 will be equals to a plus 2b. So since we already got our a, so I can write it 0 equals to 2 plus 2b, which give me b equals to -1, which is the exactly same answer like what we have just now. Then after that, how can I continue for C? Then you can continue by making any X, then after that to get your C. Or the other way that you can try to do if you want to do the equating again. So for you to get the C, then you can see that it's either you can do your X or you can do your constant. So depends on which one you want to take. So maybe equating the because for your X you have for the part for your C, you have both X and constant, right? So depends on which one you want to choose. So maybe equating the coefficient for X. So why X is easier? Because you can realize that for the part here, for the part A, you do not have any X. So for B, you have BX. So it's quite easy for us to identify. So sorry, I try to write it here. So this is how I can look at the equation. So I have for x part, I know that in front is -1. So -1x equals to, so for A, I do not have any x. For B, I have bx plus 1, bx times 1. Then after that, I have C times 2x. So meaning that I know that for the x part, I am having B plus 2C. Okay, so that part is for my x. So I have -1 equals to, since I have my b is -1 already, so -1 plus 2c. So 2c will be equals to 0. So c is 0. Then after that is the same thing lah. I get my ABC, then you can write it in the fraction form. It's the exactly same answer like what we have gotten just now. So I'm just showing you this is the other alternative that we can do. Okay. Okay, number 6. So same thing, use the formula. So 8 plus 2x minus x squared divided by x minus 1 x squared plus 2. So I'll have one linear factor, which is 8. Then after that, I have a quadratic one, which I'll have bx plus c. So x squared plus 2. So same thing, let's continue. 8 plus 2x minus x squared equals to a over x squared plus times a x squared plus 2 plus bx plus c. Remember to write it in bracket. Okay, so for this one, let's try not to expand it out. Yeah, then after that, let's try to see whether it will be easier for you or not. Okay, so same thing now. I want to get a first, so let's try to put x equals to 1. So 8 plus 2, 1 minus 1 square equals to a 1 square plus 2, which I'll have here. So if let's say now if you don't have something like you have like b times something, then it will be better that you try to write down the whole thing lah. Okay, so b times 1 plus c, then 1 minus 1. Okay, so 8 plus 2 minus 1, I get 9 equals to 3a. So I can get my a as 3. Okay, so now let's continue. So by looking at this, then what's the number that you can substitute next? I can try to let my b to become 0. Okay, so I have my b 0, then I already got my a, then I can get my c. So but the same thing lah, if you want to do the equating also can. I mean, feel free to do that. Okay, or maybe we try to do that for these questions. So yeah, I think by substituting you should know how to do. So if this question you want to do substituting the same thing, you can try to put x equals to 0 then to get your c first. Okay, so let's try to equate for x squared maybe, then we can get our b. So equating the coefficient in x squared. So I have for the front part, so the coefficient for my x squared is -1. Then for the back part, I will have a and plus b that give me x squared. Okay, so -1 will equals to a plus b, which a is my 3 and then plus b. So from that, I will be able to get my b first. So b will be equals to -4. Okay, so the same thing. Let's try to see whether which one we can. So maybe we do the constant part. So equating the coefficient in x0. Okay, so meaning for the constant part. I'm very sorry. Yeah, I realized that like when I'm writing here, then my handwriting is like not so nice compared to when I record it on paper. Okay, so for x0, for the front part, you have your constant for 8, then equal to for x0, then you have 2a here. For the back part, you will have minus c. Okay, so the same thing, you have got your a, so now you can continue to get your c. So 8 equals to 2, 3 minus c. So you will be getting c equals to -2. Okay, so this is how you get to your answer. So same thing, rewrite the whole thing again, minus x squared. So you can see that actually this method is not hard either. So it depends on you like which approach that suit you the most, and you can try them out. Okay, so 3 over x minus 1. So don't forget it's in bx plus c. So since that your b and c is both negative, then I can try to write negative. So for the bx plus c, then I can no need to put the negative anymore lah. So 4x plus 2 divide by my quadratic x squared plus 2. Okay, it's the same thing also if you want to write plus, then -4x minus 2, then x squared plus 2. Depends on which one you like lah. Alright, okay, so let's try to look at the very last part for the lesson. Okay, so let's do a very quick recap. So from the lesson just now, I hope that you can identify yourself like what is the three type for the partial fractions that you will need to know. So first one, this is basically the one that we talk about, the type 1, which you have only linear factor. Then after that, this is the type 2, which we have the repeated linear. Then after that, you have your last one, which is your type 3, which we talk about if you have a quadratic. Okay, so this is the three things that you learn today. So you can see that in the learning outcome, they try to write it there that excluding the cases where the degree for numerator exceeds that of the denominator. So you remember anything when you have a degree exceeds the denominator, it means that it's a improper fraction. So that's why when we talk about these three types, actually those are all proper algebraic fractions. But then I'm putting the very last part in your notes that it's like an extra knowledge for you, like how are you going to do if you are having like improper fraction, just for your extra knowledge. I'm not going to go in details for you. I'm just going to do a very quick explanation that to tell you what is that mean. Then after that, I'm just going to put this example as like some exercise for you to challenge yourself. Then I'm going to solve it like without explanation here, just for you to check it out. Okay. So basically, if you have something that is improper fractions, right, then you can always change it into proper fraction. Then after that, for the part that you are having the proper fraction, then you can continue by doing the decomposition that we learned just now. So the idea is actually easy in such a way that, let's say if you have 17 divided by 4. So normally if you want to do this, then what you will try to do is you will do long division, and 4 divided by 4, 4 times 4, then you get 16, then remainder 1. So you have like 4 and remainder 1. But then you can always write this in another way, that if we don't want to use like divide, then we can write 17 over 4, right? Then how are you going to write that? Then you know that you are going to get 4 plus another one, which is 1 over 4. So how you can write this is actually is your what is that called, your dividend. You divide by your divisor and you get your quotient. So your quotient plus your remainder over your divisor, correct? So meaning if I have like 25 divided by 6, then I have like 424, then 1. So you are going to write like 25 divided by 6, which here is the improper fraction. Then after that, you will get like 4, and then, you get a quotient of 4. Then after that, your remainder is 1, so it will be 1 over 6. This is how you get your mixed number, like 1, then 1 over 6, then 4, 1 over 4, right? So this is the idea of how are you going to do that. So meaning that you are going to do long division, you get an exact number. Then after that, for the fraction part, you are going to do the exactly same thing like what you have learned in example 1 to 6. Okay, so I'm just putting it here for an extra exercise for you. I think it's good for you to try out. I mean, although it's not in your syllabus, but then you can practice for your long division and the partial fraction also. Okay, so I'm just going to show everything in like a very fast speed. So if you have any questions, then you can ask me personally, but this is like an extra knowledge for you. All right, so that's it for today's lesson. So, oh yeah, just to let you know, for your if you are looking at the extra exercise, which I put in exercise 7a, so that is the question that actually for improper algebraic function fraction. So meaning what do you need to do is basically just doing long division lah. Yeah. So if you want to do that exercise, then you might need to at least go through the example 7 that I am going to do later. So if not, then you can just try to skip the example 7a. But I mean, just practice for your long division. All right. Yeah. Okay. That's it for today's lesson. Thank you.